another quadratic formula. So let's get everything on the same side. That's your very first move. 20x squared plus 21 equals 9 plus 11x squared. Okay, get everything on the left. So I'm going to minus 11x squared from both sides, minus 11x squared. And I'm going to minus 9 from both sides. And you should end up with 9x squared plus 12 on the left, and on the right you got a 0. Okay, let's see if we can find the value of A, find the value of B, find the value of C. A is how many x squared you got, so that's 9. B is how many x's you got. There are none, so that's 0. And C is how many 1's you've got, and that's 12. So I'm going to put 12 here for C. Now I just plug those into my quadratic formula. So it is x equals negative b plus or minus square root of b squared. That's just 0, so I'm not going to write it. Minus 4 times a times c all over 2a. 2 times 9. Okay, let's clean that up. Underneath the square root, you should have a negative 4 times 9 times 12 is 432. On the bottom, you've got 18. Okay, now if we stop, let's use some street smarts, and I think we can call it good right here. You need to anticipate your answer. Your answer, because you have the square root of a negative, your answer is going to be imaginary. So let's glance at the answers and see if we can eliminate some. You can knock out D. There's no imaginaries. C has no imaginaries. B has no imaginaries. So by default, your answer has to be A. So you can call that good. Okay, look at this one. G of 1. What they want you to do is only look at the line G. So only this guy. They want you to substitute in 1 for x and find out what the y is. So if you plug 1 into G, come over on the x-axis 1 unit, go up until you run into G, and when you go right 1, you have to go up 4. So the mate of 1 is 4. Okay, composition. This reads h composed g of a negative 6, or it's h of g of negative 6. And what they want you to do is take negative 6 and substitute it into g. So let's do that. I'm going to take negative 6 and I'm going to substitute it once right there for that x and once right there for that x. So g is going to be x squared plus 4 minus 2 times x. But I'm going to substitute into those two x's a negative 6. Okay, now just the arithmetic. A negative 6 times a negative 6 is a positive 36 plus 4 plus 12. So it's 40 plus 12. We should be at 52. Now this, I'm going to replace this with a 52. 52 now needs to be substituted into the function h. So let's take 52 and let's sub it into h. So now it is going to be 2 times our 52, subtract 1. So 52 doubled is 104, minus 1, you should be at 103. Okay, same thing. Take 5, substitute it into f, and looks like there's only one spot for us to do that. So 4 times 5, subtract 4, 20 minus 4, you should end up at 16. C. Same thing, except for you got to substitute it in once there and once right there. So it's going to be a negative 3 times whatever you sub in squared plus 4 times whatever I sub in, and do the exponents first. Please excuse my dear Aunt Sally. Parentheses, exponents times divide, add, subtract. Nothing really to do in the parentheses, so exponents. Gotta do this guy. Negative 7 times negative 7 is a positive 49, so you got negative 3 times 49. Let me see, let me do it on my calculator. You should have a negative 147. 4 times negative 7 is negative 28. So you got negative 147 and a negative 28, so you're at negative 175. B. Okay, this is a little different. Your instructions are right there. That's what you need to interpret. So they want you to take the rule H, and they want you to take the rule G, and they want you to multiply those two together. So H is a negative n minus 2. G is an n squared minus 5, and if I multiply those two together, it's a times problem, so it's a distributive property. I need to multiply negative n to n squared, and that's going to be a negative n cubed. A negative n times a negative 5, that is a positive 5n. A negative 2 times n, that's a negative 2n. A negative 2 times a negative 5 is a plus 10. Combine your like terms. Somewhere I think I messed up. I think I messed up right here. When I times negative 2 to n, it's actually an n squared, so this should be negative 2n squared. Because now that fits, and it should fit A. So we got a negative n cubed, a negative 2n squared, a plus 5n, and a plus 10. Alright. Okay, this is another similar, but this is a subtract problem, so it's going to be G subtract H, and sometimes subtract is harder than multiply. So G, let's find G. G is this. It's negative 2x squared minus 3 minus x. H is 2x plus 2. Okay, so if I take G and I minus H, here's what's hard about it. H has got two terms. You need to subtract the 2x, but you also need to subtract the 2. You have to subtract both terms. So let's subtract our like terms. This comes straight down because there is no like terms. There's no squares. But this guy and this guy are like terms. So if I've got negative 3 ones, subtract 2 ones, so it's 3 negatives and 2 negatives, I should have a total of 5 negatives. This is a negative 1x. That plays with negative 2x for a total of negative 3x. And that matches up with C. Okay, composition. They want you to take 1, plug it into G, and then plug that answer into F. So let's plug 1 into G. 1 right there. 1 plus 1. You should be at 2. Now take 2 and plug it into F. So take 2, plug it once right there, once right there. So it's going to be 2 squared plus 5 times 2, 4 plus 10. You should end up at 14. Okay, another one. But this one's kind of cool because they want you to take negative 8 and plug it into H. So negative 8 plus 3, that takes you at a negative 5. Now they want you to take that negative 5 and again plug it into H. So now you're at a negative 5 plus 3. Final answer, you should end up at negative 2. Okay, another graph. Look at the graph. They want you to plug 2 into F. So let's do that. Let's come over on the x-axis, find 2, go up until we hit F. F is this one. So I have to go up 5 units. So if I plug 2 into F, I get a 5. Now take that 5 and plug it into G. So let's come over here 5 units and let's go up until we run into G. And that puts us 8 tall. Okay, this one, you need to plug 1 into F. So come over 1, go up until you hit F. That's too tall. Now take that 2 and plug it again into F. So come over 2, go up till you hit F. That looks like we're at 4. Take 4 and one last time plug it into F. So come over to 4, go up until you hit F, and your ending spot should be at 8. Okay, last thing you need to be aware of, if you're going to make a mistake, you are going to make it right here, because this happens all the time in the quadratic formula and in your compositions or plugging things into functions. So here's your example. If you've got the function g of x, and that's x squared plus 4, now I want you to plug in g of negative 2. You're going to mess up right here. When you take negative 2 and plug it into that function, if you write this down, you are 100% wrong. It is not a negative 2 squared plus 4. This is bad. This is good. You have got to have that negative 2 in parentheses, because they mean two totally separate things. If you have a negative 2 with no parentheses, all you're squaring is the 2. So you're only doing 2 times 2, but then there's that negative. Your answer is a negative 4. If you have a negative 2 in parentheses squared, then you are including the negative, and a negative 2 times a negative 2 is a positive 4. So look at these answers. A positive 4 is what we intended to have, but if you didn't do the parentheses, you got a negative 4, and that's going to jack your answer up from here on out. So if you are going to plug something in and square it, make sure it is in parentheses, or you're going to miss it. So if you do not do that mistake once on the test, I'm going to be impressed.